This session will cover three topics. What is virtual network interface cards in the Oracle Cloud Infrastructure? How your instances are assigned private and public IP addresses and the use of DNS within your cloud network. How to manage the dynamic host configuration protocol, which is DHCP options in the virtual cloud network VCN. These are primary three topics we are going to cover today. Now let's listen to the intro.
Welcome to the OTech Talks podcast, where it's all about working on technologies. You will hear the latest tech information, and your host, Kashif Manzoor, brings together product overviews, how-tos, best practices, tips and tricks, and troubleshooting techniques.
Welcome to the Open Tech Talks podcast. This session number 88 and part 7 of audio series to learn the essentials of Oracle Cloud Infrastructure, which we started a month back to cover the basics of OCI. And this is what I was doing 4 or 5 months back when I switched to a new role. And I thought to share with my community and fellow members. And if you're new to the show, Open Tech Talks is your weekly sandbox for technology insights, experimentation, and inspiration with the primary objective of learning and sharing. Before I start the session, this week after the Eid holidays, that was the first Eid, and in Dubai there were rules, relaxation from COVID-19. So on this weekend, even we had a first breakfast with the friends, which I usually used to do before COVID-19, and we used to meet on the weekends and have a breakfast. So that was after a long time. When almost half 1.5 year, we sat together, we had a chit chat. So that was a lovely thing. And after the number of rules relaxed on COVID-19 in the way. Now we'll go back to our topic, and as we discussed that there are 3 key areas we are going to cover in this topic. So let's start from the first agenda item or first topic of the day, which is virtual network interface cards in OC. Or Oracle Cloud, basically. So virtual network interface cards, or VNICs, is a short name called. And the servers in Oracle Cloud Infrastructure data centers have physical network interface cards. And whenever you launch an instance or provision an instance on one of these servers, or which you have created it in OCI, the instance communicates using networking service, which is called virtual NIC, associated with the physical NIC, network interface card. And a VNIC, basically, this virtual network interface card, what it does is it enables an instance to connect to a VCN. VCN is virtual cloud network. So the VNIC is the source, is the tool, or is the card, or is the physical, which enables instance to connect to VCN and determines how the instance connects with endpoints inside and outside the VCN. Each VNIC resides in a subnet in a VCN and includes a number of parameters or items which are part of the VNIC. If we go into more detail of these items, the VNIC, which is virtual network interface card, it contains one primary private IP4 addresses from the subnet, which is VNIC is in. So VNIC need to be in the subnet, and subnet need to be definitely in the OCI if you have gone through the earlier sessions. So the one primary private IP4 address, which is either you have selected it or you have entered it, or by the Oracle. And then up to 31 optional or secondary private IP4 addresses from the same subnet of the VNIC on which it is, Again, it's either you have selected it or by Oracle. Then an optional public IP4 address of each private IP. It's again, you have selected it or assigned by you or by someone at your discretion. It's an optional component. So you got one primary private IP4 address, two optional components till now, which are 34 optional secondary private IP addresses, an optional public IP4 address. And then an optional host name or DNS for each private IP address. And we are going to cover the DHCP or DNS in this session. A MAC address, then a VLAN tag assigned by Oracle and available when attachment of the VNIC to the instance is complete. This is relevant to the primarily the bare metal instances. A flag to enable or disable the source destination check on the VNIC's network traffic. Optional membership in one or more of the network security groups of your choice. If you have attended the previous session, which is 6, which we spoke on network security groups and security roles. And then up to 34 optional IP4 addresses. Now, what is happening, most of the governments and the commercial entities have started working on IP4 addresses. And I was thinking even to have another session on IP4 and IP4 addresses. It's a new range, a new type of IP4 addresses, which is slowly started coming from a number of organizations, and it's being enforced too. So we need to go into more detail into that one. Now, definitely, we spoke on the number of items which are part of any VNIC. Now there are, let's get into, because we said primary and then the secondary, right? Secondary VNICs. So what is the role of these secondary VNICs? You can add secondary VNICs to an instance after it's launched. Each secondary VNIC can be in a subnet in the same VCN as the primary VNIC, or in a different subnet that is either in the same VCN or a different one. However, all the VNICs must be in the same availability domain as the instances. So this is the role for that one. Now, why you may require a secondary VNICs? You can use your own hypervisor on a bare metal instance. The virtual machines on the bare metal instances each have their own secondary VNIC, giving direct connectivity to other instances and services in the VNICs VCN. Or you want to connect an instance to subnets in a multiple VCNs. For example, you might set up your own firewall to protect traffic between VCNs, so the instance needs to connect to the subnets in different VCNs. And there are different types of supported for the secondary VNICs. Linux, both VM and bare metal instances. Windows, both VM and bare metal instance, which is except for the instance that use previous generation standard 1 and standard B1 shapes. That's just some of the restrictions on that one, but Linux and Windows instances. Then again, there are some limits how many VNICs can be attached to an instance, and it depends on the shapes. They can be added only after the instance is launched. Yes, they must always be attached to an instance and cannot be moved. Then what it does basically, now we got the basics of VNICs, and then what are the items to attach to it, what is the role of secondary VNICs, and on which scenario we required it. Now another important point is source and destination check. By default, every VNIC performs the source and destination check on its traffic, network traffic. The VNIC looks at the source and destination listed in the header of each network packet. If the VNIC is not the source or destination, then the packet is dropped. If the VNIC needs to forward traffic, for example, if it needs to perform a network address translation, like a NAT, then you must disable the source and destination check on the VNIC. Definitely, you need a required IAM policy, and you will get it from the administrator. You can use the VNICs monitor health, capacity, performance, using the matrices like alarms and notifications through the monitoring within the VCN or OCI. Then definitely you can create using the console if you want to use this, VNICs, existing VNICs, or create and attach secondary VNICs or update VNICs. Or you can use the APIs, which are the standard APIs, list VNIC attachments, get VNIC attachment, or delete, update. So all these are the basics configuration, which you will be doing it with the VNICs. That's what we covered from the VNICs point of view, what you need to, get the basics on the VNICs. Now, we will go to our second topic, how your instances are assigned private and public IP addresses and the use of DNS within your cloud network. So that's what our topic is, and this we will cover in detail, covering the private IP addresses, public IP addresses, bring your own IP, IPv6 addresses, and then DNS in your virtual cloud network. So these are sub parts of the IP addresses and DNS in the Oracle virtual cloud network. Now, instances use IP addresses for communication. That's where we are talking about from a private IP addresses. But each instance has at least one private address, IP address, and optionally one or more public IP addresses. A private IP address enables the instance to communicate with other instances inside the VCN or with host in your on-premise network via either you need to enable a VPN connection or a Oracle Cloud Infrastructure Fast Connect. And then a public IP address enables the instance to communicate with hosts on the internet. And if you haven't attended or listened the session, I think part 2 of this one, then where we have covered the public and versus private subnets. And then even we have covered scenario 1, scenario 2, scenario 3, that how you will be using it, IP addresses are assigned. Now, coming back to private IP object, the networking service defines an object called private IP, which consists of private IP4 addresses assigned by either you or Oracle, then optional host name or a DNS, basically, and then we are going to cover DNS in your virtual cloud network. Each private IP object has an Oracle assigned OSID, which is basically a resource identifier. If you're using the API, you can also assign each private IP object a friendly name. Each instance receives a primary private IP object during launch. The networking service uses the dynamic host configuration protocol, which is DHCP, to pass the object's private IP addresses to the instance. This address does not change during the instance's lifetime and cannot be removed from the instances. The private IP object is terminated when the instance is terminated. And if you're assigning or you have assigned a secondary VNIC is attached, then those VNICs will also have a private IP address. And a private IP can have a public IP assigned to, based on your requirement, if you want to give access to the internet. Then definitely, then you can have a secondary IP private IP address. You can add a secondary private IP to an instance after it's launched. You can either the primary VNIC or secondary VNIC on the instance. And usually, the secondary private IPs are used. Then in case of you assign a secondary private IP to an instance, then if the instance has problem, you can easily reassign that secondary private IP to a standby instance in the same subnet. So if the secondary private IP has a public IP assigned to it, that public IP moves along with the private IP. So that's, in the case of instance failover, you can use it. Then you can also, it can help you. You could, have multiple container pods running on a single instance, and each uses a private IP address from the VCN's CIDRs. The containers have direct connectivity to other instances and services in the VCN. So in that case, running multiple searches or endpoints on a single instance, you can use it. Now, definitely you need to have a required IAM policies. You can use the console or use the APIs, get private API or list private IPs, create private IPs. All these are the different APIs. Or if you want to use, then you will be using the console to give you the access to create the private IP addresses. Now we'll go to the public IP addresses. Public IP addresses is an IP4 address that is reachable from the internet. If a resource in your tenancy needs to be directly reachable from the internet, when I say resources, I mean your instance or your application which need to be accessed from the internet, then you must have a public IP address. Or for example, you are assigning a public IP address to a Bastion server, or a jumper server, or jump server, depending on the type of your instance, right? Certain types of resources in your tenancies are assigned to the directly public IP addresses. Therefore, they will have by default, you need to assign them. For example, a NAT gateway or a public load balancer, they need to be a public IP. They need to have a public IP addresses. And the instances and the public IP addresses. You can assign a public IP address to an instance to enable communication with internet. Now, these instances are assigned IP addresses from the OCI address pool, definitely. Now, this assignment is actually to a private IP object on the instance. The VNIC that the private IP is assigned to must be in a public subnet. A given instance can have a multiple secondary VNICs, and a given VNIC can have a multiple secondary private IPs. So you can assign a given instance multiple public IPs across one or more VNICs if you like. What you need is the instance must be in the public subnet if you want to communicate, and assign a public IP to so that the instance can communicate to the internet. The instance must be in a public subnet. The instance must have a public IP address. The instance's VCN must have an internet gateway. And the public subnet must have a route tables and the security list configured as per your rules. That's how when you will assign a public IP address. Now, the public IP address is defined by object called a public IP, which consists of the public IP4 address and the properties that further define the public IP type and behavior. Types of public IPs. There are two types of public IPs. One is ephemeral. Think of it as a temporary and existing for the lifetime of the instance, and then reserved. Think of it as persistent and existing beyond the lifetime of the instance that's assigned to. You can assign it and then reassign it to another instance whenever you like it. Exception from that one is reserved public IPs on public load balancers. Now, there are different scenarios on that one, and I will put it in the show notes that which you can assign characteristics, when you will assign the public and reserved IP addresses. Definitely, you need to have the required IAM policies. In any way, any actions you need to do in Oracle Cloud Infrastructure, you must be granted security access in a policy by an administrator. And this access is required whenever you're using the console or REST API within SDK, CLI, or other tool, right? So then you will be requiring the public IPs to use the APIs to access it. That's what we covered as on the public IP addresses. Now we'll go to bring your own IP address. Now, if you are interested, Oracle Cloud Infrastructure allows you to bring your own IP address space to use with the resources in the OCI. Now, it enables you to manage the IP4 CIDR blocks to align with your existing tenancy management and deployment policies, whatever you want to achieve it. Definitely, your VCN is an extension of your public network presence, internet presence, without needing to reinvent policies and management processes. If you have IP addresses, hard-coded insert devices, or built architectural dependencies on specific IP addresses, using bring your own IP, you have a smooth migration to the Oracle Cloud Infrastructure. You can have IP pool management, you can have IP reputation when some internet services rely on contiguous IP address spaces, such as full span of IP addresses from 1 through 255, and acts as a trusted connect point. So now let's go in a more detail that what are the requirements and preparation. You must have ownership of the public IP4 CIDR block you want to import into Oracle Cloud infrastructure, and the ownership must be registered with the supported regional internet registry. Oracle validates the ownership of your addresses through American Registry for Internet Numbers, then RESOX IP, Europeans Network Coordination Center, then Asia Pacific Internet Information Center. So all these are registries which you need to have, regional internet registry. There are some limits and quotas. Your address can only be imported to a specific Oracle region. You can bring your own IP with an IP4 CIDR block that is a minimum of 24/ and a maximum of /8. You can't bring the same address range to more than one compartment at a time. You can bring up to 10 IP4 address ranges to your cloud infrastructure account. And then bring your own IP is not available with Oracle Cloud Infrastructure free tier or pay-as-you-go services. Now, there are definitely steps involved into that one. From a tenancy point of view, Oracle, then regional internet registry, and you will be importing the IP4 CIDR block, your own, then you issue a verification token, then you modify and goes back to the registry, and then it get certification registered, and then Oracle provisions the bring your own IP, your addresses on the side on your VCN. Again, coming back to, you need to require your own IPM policies you can use through the console or using the APIs. Now we'll go to the IP pools. This is also our part of the basically addresses and DNS your VCN, which is covering as a second topic. A public IP pool is a set of CIDR blocks allocated to a tenancy. These CIDR blocks can be all or part of bring your own IP CIDR block. Public IP CIDR blocks assigned to a pool are only available for your tenancies. Public IP pools are available as a source for IP allocation and when launching a NAT Gateway, a load balancer, or compute instance. And you can add more IP CIDR blocks to a public IP pool at any time. What you need to do, you can reserve individual IPs from your public IP pools. These reserved IP addresses can be attached to your resources. You can launch resources from with an IP directly allocated from a public IP pool without previously creating a reserved IP for that resource. You can delete the entire public IP pool or certain IP CIDR blocks within the pool, providing none of the IP addresses are currently attached or reserved. If you want to use the IP pool within your bring your own IP addresses, you need to import your addresses. And to reserve Oracle supplied public IP addresses, you need to select Oracle as the public IP pool when creating the reserved public IP addresses. There are certain limits to it. You can create 1 or up to 10 public IP pools in a compartment. Then definitely you need to have a public IP pool can have a 0 or a more IP CIDR ranges assigned to it. You need to have a required IAM policies. Then you can use through the IP console or using the API. For example, create public IP pool or delete public IP pool. And then we will go to an IP4 addresses, which is IP4 addresses is IPv6 basically. IPv6 addressing is supported for all commercial and government regions. And when you're creating your virtual cloud network, you choose whether a VCN is enabled for IPv6 or you can enable IPv6 on existing IPv4 only VCNs. IPv6 enabled VCNs use a 56 IPv6 CIDR block, and Oracle signs a 56 globally CIDR block, reputable IPv6 CIDR block to the VCN for internet communication. All subnets are, 64 CIDR blocks. You can either permit or prohibit internet communication to a subnet by specifying the public or private subnet level flagging. Now, only the networking gateway supports IPv6 are the dynamic routing gateway, local peering gateway, and the internet gateway. Then both inbound and outbound initiated IPv6 connections are supported between your VCN and the internet and between your VCN and your on-premises network. Definitely, there is a new way to assign the IPv6 addresses. IPv addresses are having a more range, CIDR, and then it's allocates basically global unicast addresses. So then, whenever you're enabling that one, then you need to follow the rules of IPv6 addresses, and Oracle gives you enables you to learn and get the basics knowledge on that one, and then you can assign it. What is the format of that one? Routing or covering how you will assign it. And then you also need to definitely put the security rules for IPv6 traffic. Default security list, which we added, usually default security list, those are for IPv4, but when you are using the IPv6, then you need to manage a number of things on that one. For fast connect, VPN, everything. And then DHCP, configuration, V6 configurations, load balancers. So all there is a comparison, from a characteristics point of view. Now, definitely we see addressing type supported. Yes, IPv4 is supported. IPv6 is optional per VCN. And then IPv4 traffic is supported on all gateways. IPv6 traffic is supported only with the Internet Gateway, Local Peering Gateway, and DRG, both inbound and outbound initiated IPv6 connections. Then the VCN size is, CIDR block 16 to 30, and here is CIDR block 56 only. Subnet size can be 16 to 30 with 3 addresses reserved in each subnet by Oracle, first 2 and the last one. And in IPv6, 64 CIDR blocks only with 8 addresses in the subnet reserved by Oracle, first 4 and last 4. Then definitely, private IPs and public IP addresses, IP address assignment, private, each VNIC gets a private IP4 address. And then you decide whether a VNIC is an IPv6 enabled subnet gets an IPv6 or not. Internet access, you can, with the access you choose through the what we call as public IP address. And then with the IPv6, you control whether a subnet is a public or a private. Then there are a number of options, primary secondary labels, host name. You can assign host name to IPv4, but you cannot assign host names to IPv6 addresses. Route rule limits, which we need to have a service limits. IPv4 and IPv6 route rules can reside together in the same route. Security rules, similarly, reserved public IP addresses supported in the IPv6 not supported. So that's how you will be creating through the console or APIs. That's a similar topic on that one. Now, this is the last point on our IP addresses and DNS in your VCN. So we have covered the IP addresses, which is private, public, bring your own IP, IP pools, IP addresses, IPv6 addresses. Now we're covering the DNS in your virtual cloud network. The domain name system, which is DNS, enables computers to use host names instead of IP addresses to communicate with each other. And you have a choice of, to pick up the DNS name, and you can do it by choosing it on each subnet in the VCN using the subnet set of DHCP option. And it's similar to when you are choosing or configuring the route table and the security list. You can use the domain name server DHCP option to specify the DNS type for the associated subnet. If you change the options value, either restart the DHCP client on the instance or reboot the instance. Otherwise, the changes does not get picked up until the DHCP client refreshes the lease within 24 hours. Now, there are default choices, Internet and VCN Resolver. And these choices are provided by by Oracle. And if you want to choose Internet Resolver, lets instances resolve hostname that are publicly as published on the internet. The instance do not need to have a prior internet access by way of either an internet gateway or a connection to your on-premise network, such as through the VPN or through a DRG. VCN Resolver lets instance resolve hostname which you can assign of other instances in the same VCN. And by default, new VCNs you can create use the Internet and VCN resolver. If you're using the networking API, then this choice refers to the VCN local plus Internet. Now you can have another custom resolver. When you use the custom DNS resolver, then use DNS reserved servers for your choice for resolution maximum 3. This could be DNS servers that are available through the internet. For example, for Dine's Internet Guide in your VCN, in your on-premises network, which is connected to your VCN by the way of IPsec VPN connection. When definitely you assign initially when you're creating the VCN and subnets, you may specify the DNS labels for each. And subnets DNS labels can only be set if the VCN itself is created with the DNS label. And these labels, along with the parent domain of like Oracle VCN from the VCN domain name and subnet domain VCN domain name, like VCN DNS label.oraclevcn.com, or a subnet domain name, subnet DNS label.vcn DNS label.oraclevcn.com. Definitely, there are some certain requirements. From that angle, that VCN and subnets, what are the numeric values, what are the name you're going to choose it, then how the validation and generation of the host names is working. If you set up a DNS labels for the VCN subnet, then Oracle validates the host name for DNS compliance and uniqueness during instance launch. If either of these requirements isn't met, then the launch request fails. That's part of that one. Then DHCP options for DNS. If you want to choose that one, I think that's another our topic, which is the third topic which we are going to discuss today, is on the DHCP options. Dynamic Host Configuration Protocol options in a virtual cloud network. The networking service uses the DHCP to automatically provide configuration information to instances when they boot up. DHCP lets you change some settings dynamically, others are static and never change. For example, when you launch an instance, either you or Oracle specify the instance's private IP address each time the instance boots up, or you restart the instance DHCP client. DHCP passes that same private IP addresses to the instance. The address never changes during the instance's lifetime. That's how it is configured. Now, definitely, the networking service provides DHCP options to let you control certain types of configuration on the instances in your VCN. You can change the values of these options at your, whenever you want it. And each subnet in a VCN can have a single set of DHCP options. The set of options available to all instances in the subnet, each VCN comes with the default set of DHCP options. Definitely, domain name server, it comes with the possible value Internet in VCN resolver or customer resolver. Then definitely will have initial value and the default value. Then the search domain, a single search domain. If you set up your VCN with the DNS label, then it search that one. So when you create a subnet, you specify which set of DHCP options to associate with the subnet. If you don't, then the default set of DHCP options for the VCN is used. And definitely you need to have a required IAM policies. The important point on DHCP option is whenever you change the value of the DHCP option, you must do is to change it. It takes time to affect take effect on the existing instances, either by restarting the DHCP client on the instance or reboot the instances. Now, what you need to do is you need to make sure to keep the DHCP client running so you can always access the instance. If you stop the DHCP client manually or disable networking manager, which stops the DHCP client on Linux instances, the instance can't renew its DHCP lease and will become inaccessible when the lease expires, typically within 24 hours. So do not disable network manager unless you use another method to ensure renewal of the lease. And stopping the DHCP client might remove the host route table with the lease expired. So, loss of network connectivity to your SCSI connections might result in loss of the boot drive. Definitely, when you want to do it, you need to go ahead to the either console where you can have a VCN set of default DHCP options, or create a new set of DHCP options, or you want to use the APIs, list DHCP options, cat update, create DHCP options. So these are the values. Now with this, we have covered today 3 topics. Virtual network interface cards in OC, how your instances are assigned, private and public IP addresses, then how to manage the dynamic host configuration DHCP options in your VCN. Thank you so much, and this was the part 7, or this is the part 7 of our audio series to learn and improve our knowledge on the Oracle OCI, which is the basics, essentials, frankly, to get the knowledge on OCI. And definitely, once these sessions are over, then we are going to cover and we are going to take the scenarios to build or deploy the application and then configure all these options. In the next session, we will cover dynamic routing gateways, 5 VPN, fast connect, access to the internet. I think most probably there will be 1 or 2 more sessions to wrap up this series. Thank you so much once again. Have a blessed life, and please share your feedback, comments, and this show is now available on Spotify, Google Podcast, and Apple Podcast, and so many other podcasts. Thank you so much, podcast directories, frankly. Thank you so much. Have a blessed life. Bye-bye.
Thanks for listening to the OTech Talks podcast, and be part of Tech Talks at otechtalks.tv. It's a turf to share ideas, insights, and innovations.